Is it all ready?
You're on.
All right. Welcome back to the new year, everyone. I know there's a lot of sickness going around, and hopefully you've all survived. I guess Ruth and Josh, I'm not sure if you're seeing this. I know you had some issues, but good to see you. I want to go over 2 lessons today. For homework for EBA, today 51A and 51B, and then we'll have 52 for Monday. So I wanted to get through that because otherwise, if we wait till next Tuesday, you know, we've got 3 or 4 lessons to do, and they're calling for some snow possible next week. So we'll see. Now that's possible. Don't get your hopes up. Down further south, they're calling for a lot more. Around here, the last I saw was 1 inch on Monday, but that could change and be nothing. All right. If you remember last year, we finished by doing this grid coordinate, Cartesian coordinate plane. And do you remember this line, what variable we're going to assign to that? X, right. And what are we going to do for the vertical? Y. Why? Because no. So this is very important. X's and Y's. You are going to have this a lot, both in what we're going to go through today and many other things. And what was this center called? The orthodontist? Is that what we said? The
origin.
Origin. Good. That's the origin. So that's, we always do the X value first and then the Y. And we said anything in here, in this quadrant, will actually number them 1, 2, 3, 4. Anything in here has a positive X and a positive Y. This has a negative X and a positive Y. This has a negative X and a negative Y. And this has a positive X and a negative Y. So you can see that each quadrant is a little different. So for example, if we had a coordinate of 3, 4. Let's just put a couple of these tick marks out here. And they should be more even than that. All right. So if we had the grid coordinate of 3, 4, that's the X value, that's the Y. So we count over 1, 2, 3, and up 1, 2, 3, 4. So that's 3, 4. Positive, positive. Now let's say we had, I don't know, negative 2, 5, or something like that. So the negative, X is negative. We're coming this way, so that's, this is the origin, 0, 0, going that way is positive. On the x-axis, this way is negative. On the y-axis, that's positive, that's negative. So negative 2, 1, 2, up 1, 2, 3, 4, 5. Negative 2, 5. Down here, they're both negatives. So let's say, I don't know, negative 1, 6, all right? Or negative 1, negative 6. So we're going negative 1, 1, 2, 3, 4, 5, 6. That's negative 1, 6. And here's, let's say 1, 2, 3, 4, 5, 6, 1. 6, negative 1. So we go 1, 2, 3, 4, 5, 6, and negative 1 out there. So you should have had this in some prior math classes, but just this is very, very important. Plus, plus, minus, plus, minus, minus, plus, minus. Okay? Now, what we're going to do is we're going to start connecting the dots or the lines. We're going to make lines. So, they've always said the shortest distance between 2 points is a
Root.
Straight line. The
Yeah.
shortest distance between 2 points is a straight line.
Okay.
All right? So if you're going to travel somewhere, the shortest distance from point A to point B is a straight line. Now, like for example, if we want to travel to your house, the shortest distance, we aren't going to do the shortest distance because, you know, there's no direct road that goes over to your road. So we have to kind of weave around. You know, they often say, as the crow flies. Well, the crow isn't going to follow the roads. The crow could care less about the roads. The crow's, you know, this is again an expression, it's going to go a straight line. So the shortest distance between 2 points is a straight line. So we have this line, and we're going to talk about linear equations. So think of line as a root word, and we're going to add linear equations to that. So the key thing here is we have a line. And that line will have 1 or 2 variables. We'll have a lot of variables that will have y equals some value of x plus where it crosses the y-axis, and we'll get to this in a little bit later. But this is an example of 2 variables. M is the slope, and b is where it crosses the y-axis. But m, or y and x, are 2 variables. So we're going to have a lot of that coming up. But the point is, we have a straight line. That's not quite going through the points, but close enough. My artwork's not always the best, and so whatever. Now, if we look, let's look on page 206. 206. We're going to have a lot of graphing lines now. And we're going to do one method now for a little while, and then we'll have another method in a few other lessons. So if we look at the top of page 206, it says graph y equals 2x minus 1. So, all right, so that is a linear equation. It's going to make a line, a straight line. So how do we do that? Well, in the book, they do it horizontally. I'm going to do it vertically, kind of like this way better. We're going to plug in values for x and see what the corresponding value of y is. All right? So we want to plug in some easy values of x. And the easiest value of x that we can start with is 0, because that will cancel out that term. Anything times 0 is obviously 0. So if that's the case, if x is 0, Melinda, what's y?
0, right?
No. 0 minus 1, what's y?
-1.
-1, right. So our value of y is -1. All right, so let's put a value of 1 in for x. All right, Serena, what's 2 times 1?
2.
Minus 1?
1.
1. So when x is 1, y is 1. All right, Janaya, let's plug in 2. What's 2 times 2?
4.
Minus 1?
3.
3. All right, so now we have, it's always good to get 3 coordinates. Now, like I said, the straightest distance, the shortest distance between 2 lines is a straight line. But just in case you do make an error in your calculations, it's good to have 3 points so you can make sure they truly line up. So let's see what happens. 0 minus 1. All right, 0, -1, right there. 1, 1, right there. 2, 3. 1, 2, up 3. So if we had a yardstick, we would connect those and they make a straight line. So again, it's good to have 3 points, because if you made a wrong calculation and had it out here, you'd say, whoa, you know, which one is right? So it's good to do 3 points. All right, let's look at the next example. I guess at the bottom of the page. Y equals negative 1/2 x plus 2. All right, again, I like the vertical x and y. Again, pick some values of x that make it easy. I mean, as you can tell, a line is going to have an infinite number of values, so pick some easy ones. And it's always good, again, start with 0, because that cancels that out. So when x is 0, what's y, Melinda?
Y is 2.
2, yep, because that cancels that out, so you're left with 2. Now, all right, we got a fraction in here. So what's really good is to pick a number that will cancel out with the denominator. So let's pick the value of 2, because dealing with fractions sometimes is a little harder. So let's deal with 2, or what we'll make when x is 2. So we see that will cancel out the 2's. So Serena, we have negative 1 plus 2 is?
1.
1, right. So now the book does it with the negatives. Sometimes, we multiply a negative times a negative. Let's make
will make America great again. We will make America great again.
Great.
That was a Christmas present from Tommy.
All right, so let's pick 4, because 4 divided by 2 will be nice. All right, so Janaya, 4 divided by 2 is 2. We have to have the negative, so negative 2 plus 2 is 0. All right, so now we have 3 points. Let's make sure they make a straight line. 0, 2, 0, 2, okay. 2, 1, 1, 2, 1, and 4, 0, 1, 2, 3, 4, 0, and you can see that indeed is going to make a straight line. So that is a linear equation. We have a line that makes a straight line. Again, there's an infinite number of points that could be out here, right? It just goes on forever, this way, on forever. To get some values that make sense, again, pick 0 is always a good start, because that'll cancel out that first term, and you're left with where it's going to cross, right there, 0, 2. Then pick numbers that will make this equation a little, especially when you have a fraction. Negative 1/2 and 2, all right, that'll cancel out, but make sure you remember the negative. All right, let's see. Does he have one more? All right, 51(3). Y equals negative x. Y equals negative x. I should have color coordinated better than this, but whatever. Y equals negative x. Again, I like the vertical. You can do, it's good to make a table of whether it's horizontal like he has in the book or vertical. I just like it going up and down. Now, this is a little different in the fact that we don't have any other numbers out here. So, again, good to start with 0. So what is negative 0? Serena? Nothing, right? Still 0.
Okay.
So it's all that. All right. So when x is 1, y is negative 1.
So
When x is 2, y is negative 2. So let's see, what other colors do I have here? 0, 0, 1, negative 1, 2, negative 2, and again you can see it if I connect the dots. I was never good at that. All right, negative 2. All right, does that make sense? Make a little chart, a table plug in values of x, make them simple, and then plug in the numbers and make sure you have a straight line. Now let's go over to the next page, 208. And he's got some different kind of, he loves these next type. So where you only have one variable. So if we have 51.4, he says x equals -2. X equals -2. What color? I didn't use the prime. I guess I used one. All right, x equals -2. X equals -2. Well, you don't need to make a chart. There's no values of y necessarily. X equals -2. Remember, this is our x, this is our y. So where does x equal -2? Right here. And y is any values. So what you want to do, there we go, make a straight line at x equals -2. Then you'll have at the top of the next page y equals 4. All right. Again, we know this is our y-axis, so we're going to go up to, or this is our y-axis. 1, 2, 3, 4. Y is 4. So that means x is every possibility. So y is 4. So when he has a value of x, you're going to have a vertical line. Y's value be horizontal line. But again, just find out where the value is, -2, and then just make your line. Or x is -2, y equals 4. He loves these. You will get a lot of practice with those. They're not, obviously not difficult, but it's easy, and I've done it too, to swap them around to get confused. But just when it's x is negative, go to -2, make your line. Y equals 4, go to where y is 4, make your line. All right. In the interest of doing the video, I think we'll come back to do more problems without the video. All right, because I want to do one more lesson. All right, any questions on this for the time being? We'll come back and look at this in a little bit.
On the next page.
All right, so two concepts in lesson 52, and again, Janiyah, this will be for Monday, Ruth and Josh for Monday. Now the first part is, we've had some of these, he's just making it a little more complicated. So example 52.1 at the bottom of page 211, a over x plus b over x plus y. So our denominators are not the same, right? Obviously. So now we know we need to get a common denominator. Well, our common denominator is, well, there's nothing we can do other than x and x plus y. All right? And as we did before, I think this is still a good practice to help you figure out what to cancel. Put all of this in parentheses and put what you have in the denominator up here, and let's see what cancels out. All right, we see the x cancels out. So now we're left with a times x plus y. Here the x plus y cancels out, so we're left with b times x. I don't think he necessarily multiplies that out. You know. Well, he does. He says there are many equally correct forms of the answer. We could multiply that out, but that isn't necessary. We could multiply that out too, but this would be good enough. Let's go look at 52.2. All right, 52.2 is 4x plus a over a plus b plus c over x. Again, we do not have a common denominator, so we know we've got to get our least common denominator. Again, there's no magic or no match there, so it's got to be x times a plus b. All right, x times a plus b. The a plus b cancels out, but now we have 4x times x. What's that going to be, Melinda? 4x times x.
4x to the second?
4x to the second, good. And we'll cancel that out. And then, but you have to multiply, all right, that canceled out. Then x is times each term, so that's 4x to the second, so that's plus ax. So you have to remember that's times each term. Here, that'll cancel out, so we're left then with c and then the a plus b. Now again, I don't think he necessarily, well, he did, you know, we could multiply that out, do the distributive on that. You don't have to. So now let's get a little more complicated. Let's look at 52, the one at the bottom of the page. So we have a over b plus c minus x plus d plus m over k. Wow. Well, again, we do not have common denominators, so our denominator's got to be the multiplication of, and that's a 1, so k times b plus c. Let's put all that in parentheses, k times b plus c, and let's see how this works out. All right, the b plus c cancels out. What's left, Serena?
Okay.
AK, all right. Now here, nothing cancels out. There's nothing in the denominator, so we gotta say
Okay.
minus x k b plus c. So see, that x has got to be multiplied, and the best way to do that is just put it outside here. Here, the k is going to cancel out, but now we're left with b plus c times d plus m. And I don't think, well, yeah, he doesn't multiply all that out. You know, you don't need to do that either. You don't have to figure out, that would be a lot more terms. So get your denominator, and I recommend doing something like this so that'll help you see what cancels out and what you have to multiply.
Is the first one supposed to be a K? AK?
Thank you. Just want to see if you're paying attention. Okay, good. All right, so again, not too difficult. It's getting, I was going to say, a little weirder. I mean, all these variables flying around, but there's a point to all this as we keep on going on here. All right, the one other concept, Mr. Saxon, it's interesting how he puts multiple concepts in a lesson that are totally unrelated. So this is called overall average. Now remember, when you think of average, you think of it's the sum of a bunch of numbers divided by the number of numbers. So let's say, I don't know, what can we say? Since Josh will be watching this, his Saquon Bark, oh no, he doesn't want Saquon Barkley, that's right, he's Penn State. Nicholas Singleton ran for 85 yards, and Katron Allen, what was it, 113, and some other guy, the quarterback, Drew Aller, let's say he ran. This is Penn State football. So there's three guys. So how do we get the average of those three? Add those three up. So that's 8, 11, 5, 13, 14, 241, and divide by what?
3.
3. So
that's
that's
8.
easy, 80 and 1/3, all right? So that's pretty simple, the average, and sometimes, and I think we've had some lessons here, sometimes you'll get a situation, they'll say, hey, the sum of the numbers is 241. They'll give you one or two, maybe, well, they can't give you just one. They'll give you two of the numbers, and they'll say, what's the third? So you have to add those up and then subtract from there to get that third. But now we're going to talk about the average of the averages. In other words, let's say, all right, those are the Penn State running backs, and let's just for sake of making an easy number, I'm going to take that down to 2. So their average was 80 yards that they ran throughout the game. And they played Boise State, and they had a really good running back. He ran for 104 yards or something like that. And I don't know, the quarterback might have ran for 22 yards, and I don't know, another running back might have ran for, I don't know, 6 yards. Let's see, that's 6, 12, 3, 4, yeah. 3 will go into that. So average of the Penn State was 80, and 3 into 132 is 444, all right? So that was Boise State, that's 44, all right. So here's the big question. What is the average of the running backs for both combined? Well, it's not doing this. It's not doing this. It's not adding this up and say, hey, that's 4, that's 12, divided by 2, that's 62. That's not the average. The average is you have to figure out the total, and we have all these numbers here, so it's not going to be too bad. The average is going to be the total of all these divided by the number of entries. You're not going to always have that. So this is 80 for 3, and that's 40. A lot of times this is what you'll have. They'll say the average of 3 of something was 80, the average of 3 of something else was 44. So what we have to do is multiply that out, because that's what this was, 240. And we don't necessarily care in this case now what were the individual numbers. We just know the grand total was 240. 3 times 44, that was 132. Again, we don't necessarily need that. Then we add all of that up, 2, 7, 3, and who's got a calculator? 372. What do we divide by? What number?
The first 2, no, 1, 3, 6.
There are 3. What?
6.
6, right. The total number. So what's 372?
62.
Pardon me?
62.
62.
Yes.
Yeah, it is.
Yes, it is.
Now, I think this worked out this way because we had the same number of 3 and 3. If we would have had a different number, as we'll see in some examples here, I mean, that is too, I think it's because we had 3 of each. Let's do another example. Let's see what does he have in the book. All right.
I was in my car when you called before, so I couldn't answer.
All right. So it says the average of every, okay. The average of the first 6, let's do example 52.5. The average of the first 90 numbers was 4. So the average of the first 90 numbers was 4. The average is 4. And there's 90 numbers.
So you
What would have been the total?
want
If we would have had
Oh.
4 numbers and we got the average, they would have totaled up to 360. Because remember, the average is the total divided by the number. Now they're telling us the average and the number. So to get that total, it's 4, cross multiply and divide or whatever, 4 times 90, 360. So that would have been our total, because the average over 1, all right? Then what does it say? The average of the next 10 numbers was 6, so that was
6
10
times
numbers.
10, so 60.
So 6 times 10 is
60.
60. All right, so we multiply the average times the number of numbers. Again, this is kind of what that means. Add those up, 4 and 20. Now what do we divide by?
10.
10, right. The number of occurrences. Not by 2, but by the number of occurrences. And obviously that's
42.
pretty easy, 42. And what am I doing wrong?
Still recording?
Oh. Actually, yes.
What?
The number of numbers, this was the average, I'm wrong. It was the number of numbers, 100. And that's 42. Yeah, this was the average. I'm sorry.
Oh.
This was the average. I know it made sense that that was the number, but this was the number of numbers. So 90 plus 10 is
4.2.
100. So 420 divided by 100, 4.2. Did I totally confuse you with that? Let's do another problem. Let's do number 2 in the homework. Says the average of this first 6 weights, so we have 6 weights, and the average is 15 pounds. So what would have been the grand total there? 6 times 15?
6 times 5 is 30, so 90.
90, right. We know that's a 90. And then it says the average of the next 14 weights was 30 pounds. So who's got a calculator? That's a little, well, that's not, it's 420, right? Well, no, you take the 0 away,
Yeah,
and then
'cause
it's
it's
3 times
12.
14. So you got
420.
420, right? All right, Melinda, 420 plus 90, 510. Now, all right, this was the average.